In this video, we will see how to create a tunnel cross-section. First, we will open a tunnel designer file by creating it or just using an empty one. Then we enter this file and in this file, so in OpenTunnel, we will go to Utilities where we can manage the different catalogs. OpenTunnel is working with catalogs, and from these catalogs, you can copy the different templates to your project. So having different templates, finally, in your catalog and the one in your file, so they can live separately. We have already existing template, and we will create a new template for cross-section, and the type will be conventional. Give a name to the template. So we go in a specific 2D temporary workspace where we can see this WP point, so working point, where we will have, where the cross-section will be attached to the alignment in 3D. You can see also that we have a special menu at the top, but you can also go to the drawing if you need more elements and more function to draw different things. So we will draw the cross-section. Here we have a usual shape for a tunnel. So we draw a line of 10 meters from the working point at 0 degree. Then we will draw, a vertical line at the end, again of at the working point 10 meters. Okay. Note that these lines, both these lines, are construction lines. Why do we do this? Because we will use them for parametric, and we don't want to see these lines when we place the cross-section, so we can after undisplay construction elements. We can draw also a line that will help us to define the different things. And now we can start with the shape of the tunnel. So for this, we will go back to primary elements and change the symbology back to solid to make a difference. And here we will draw a vertical line, okay, of 10 meters, excuse me, going up here. Then we will extend this line by 2 meters to the bottom. So finally, we have 8 of the vertical line on the tunnel of 12 meters with 2 meters under the origin. We make a symmetrical copy, so a mirror copy vertical from this line. Then we can draw a single line that will link the two sides and which is the bottom of our tunnel. Finally, we will create an arc of 10 meters radius at the top, 180 degrees, linking both sides of the tunnel. And here we have the cross-section of a tunnel. We will put some parameters to this through constraints. So we need to create first a complex shape of this. Otherwise, if we do it afterward, it will delete hot constraints. So now we can go to the constraints menu. And the first thing that we will do is we place fixed elements. So that means that we fixed both ends of the first vertical line, which will be our vertical reference. Then we define that the origin of the horizontal line is coincident with the vertical line, and we have 90 degrees, so perpendicularity between the vertical and the horizontal line. So these are our reference for the different elements. And from this reference, we can say that we have, so that the wall are parallel to the vertical, so both walls are vertical. Then we have the bottom line, which is parallel to the horizontal. Then we will define that our element is symmetrical. So first we will define a new variable. So the first variable will be the reference height, which is at what distance from the origin of the template will be the bottom of our tunnel. And in our case, we will place as default value 2 meters, which is the value that we have given. Then we will add another variable that will be the wall height. And this wall height, we will give as default value the value that we have here, which is 10 meters, which is the value of the wall above the reference point. And finally, we give a width, and the width will be, by default value, it will be 20 meters. Excuse me, the wall height will be 12 meters, so with reference to the bottom and not to the point. And the value of the width by default will be 20 meters, and the radius is half of the width. That means 10 meters. Here, so let's go back to the width and define 20 meters. Okay, now we will apply these parameters on our file. So the first thing, we will define that we have a symmetrical cross-section, so that both walls are at the same distance from the center line. And attached to that, we can define that the length of the width, so from the bottom point to another bottom point, is equal to the width, which is 20. In the same way, we can define the height, so the reference height from the attachment point, which is 2 meters in this case. And finally, so the wall height, and we will define this height on both sides. We could have placed also that both elements are equals. So there's many different ways to do it. We can say also radius of this arc. So we don't need to put the other elevation, because due to this, we will have the value and it will change. So let's change to see if it's okay. So we change the reference height, it's okay. We change the wall height. Okay, so both walls are increasing, and we change the width. And it works also, so the radius automatically change. So our cross-section has been defined like that. Now, we can define this as an excavation. So for that, we press excavation, and that gives the tagging menu where we define the excavation, so the type and the template, and we tag the element. So the element automatically assigning the template element is changing as color and line style. We will change the background value, so we better see on white, especially when we record. Okay, so we can see here the limit of the excavation. Let's go back to our menu. Okay. From this now, which is the excavation, we can define the lining, and we will define the lining with two different shapes. The first one will be the external extradose lining, and the second one the internal. So we do a parallel copy. We define that this copy is effectively will be kept parallel when we make some variation. So we define that both lines are parallel to the existing one. Okay. And we create a new cross section, which is a distance lining to excavation that we will default to 1 meter. And we define that the distance between the right wall to the excavation, right extradose wall, is this distance. We will define that we have the same on the other side, so the left wall has the same distance from the excavation, so also 1 meter here. That we have also the same distance from the bottom to the excavation. We could have put different values if necessary. And finally, we define also that we have, so we check this distance, and we can check that also everything is acting as expected. So everything is kept parallel at the same distance all around. Then we can register this element as lining extradose, so taking the good element, but you see that this element cannot be tagged because it has already a tag. So in that case, you must first delete the existing tag because we cannot add two tags. So we delete the existing tag. Then now we define the tag on this element. Assigning also the template element, and we accept it. So now we have defined two elements, the excavation and the external intradose. And when you put your cursor on top of the element, you can see the tag value. Then we will do again a parallel copy from this external intradose to the internal intradose. But in this case, we will have a little more complex intradose definition. So for that, we will first drop the complex and the line string to have separated elements for this. When we drop, we lose the tag because we lose the complex element, okay? So we will do some parallel copies at the bottom to define edges. So here we make a copy of parallel copy of 1 meter and 1 meter here. Then 1 meter on the other side. Then we will adjust the length of the element to define an edge here. Okay, we will make a symmetrical copy from the left edge to the right edge. So first cutting this, okay, then we make a symmetrical copy on the other side. So deleting this element and just make a symmetrical copy of the edge on the other side with the horizontal element too. And the same, adjust the end of the elements. Then we can link these elements to make a complex shape. So be careful not to use an existing constraint element, otherwise it will remove the constraint. So be sure to take, so that's why I choose manually to point to the element, to be sure, mainly at the horizontal part, to choose the last element I have created and not the reference dotted line. Here I have created this complex shape. Now I can put constraint in it. I will for that define new variables. So my first new variables will be the wall lining thickness. Then I will add a new constraint, a new variable, which is my bottom lining thickness. That can be different in that case. Then I will add two other variables, which is the edge width and the edge depth. I leave 1 meter for this, and I will check when I change the value that it's okay. So putting back some constraints. So first define that all these new elements are parallel to, so the vertical elements are parallel to my center line, which is fixed. Don't forget the edge side, which is also vertical. Then my edge, which is parallel to my fixed horizontal, my bottom line, which is also parallel to the fixed horizontal line, and both edge here. So now I have defined all this. I will create a new constraint saying that the two circles have the same center. So I'm sure that when I change this, it will be centered. I don't need to define another variable. And finally, I can assign my different values. So first, I say that both edges have the same width. So they have the same distance to the center point. It's symmetrical cross section. And I define also that the edge distance, so the edge width is defined. So first I define, the wall lining width on one side. Yes. I define it on the other side. I could have said that also these are symmetrical. There's always different ways to constrain an element. Then I define the thickness of my bottom lining here. Then finally, I define the edge width. I need only to define one because I have put a constraint that this is symmetrical. And in the same way, I define the 8 here. But this one, I need to put it on both sides, okay, because there's no, or I could put also that both edges have the same elements, same element length, which is another possibility. Here I have finished to define the constraints, so I can check that everything is okay by changing the different values, okay, and check that everything is okay. If it's not okay, so you have to delete the constraint and restart to place them. So everything seems to be fine. So now I can tag this element. So I call the tagging element for lining introduce, apply the template definition and tag the element and accept it. So we can see the change of color, and if we put our cursor on top of the element, we can also see that the tagging value is correct. So I can save it. We go back to our standard model, and then we can define, so in the menu, you can see that we can define the tunnel template linings. So that means that we can define the different parts of the lining. So for that, we will define some elements that will cut this lining into pieces. So for that, we have defined element as construction element, and we draw lines to separate the different parts of the lining. So we'll place a line at the top of the vertical wall on both sides, and we will isolate the edge, for instance, both in horizontal and vertical, so by line that are crossing the different elements here. And now we can define the lining parts. So for that, we will press the icon lining parts at the top left. We can give a group name of this lining element. So here we define, for example, concrete lining, and a prefix part, for instance. Then we will tag the elements. So it's like defining a region. So we click inside the region, it will find the different elements, and you accept it. In the bottom, there is only the half. So just press the Control key and give a second click in the second part, and we accept it. Then we can do the same for the edge. So just identifying this. Okay, and accept it outside. Yes, that is correct. Okay, and I can do the same so for the edge, left edge, and right edge in two pieces, because I have my construction line which is inside the region, but I define only one element. Okay, and I can check this is correct by saving changes. So I go back to the menu, and in the menu, now in the display of the cross-section, I have the different parts the number of the parts that are displayed. So 1, 2, 3, 4, 5, 6 in the middle. And these parts are listed at the bottom. You can see part numbers, the categories. So the categories is the group that I have defined, lining parts, okay? And I can define the material for each lining part. So these are concrete lining parts. So I can define the type of concrete. So I left it as lining part, but I could change use ceiling and other parts. But here I define the type of concrete that I will use. So I will use a C35-45, which is quite hard. And I will give for the edges little more strength will be higher, C45 for the edges. I don't need to save. This is automatically saved. Okay. Now, you see I have the different parameters here, so I can change. For instance, if I want to reduce the distance from lining to excavation to 50 centimeters, so 0.5, automatically my template is readapting to the new values of the variables. Now we will define the excavation subspace, so the different parts in the excavation where we can assign some materials. So for that, I go to subspace definition. That will give me a display of my excavation elements inside my 2D space, temporary 2D space. I will change again the background color so to better see what I'm doing. Let's put it in white. Then I will define the limits of the different ground. So it's something which is approximately defined. So for that, I will use, for instance, circular arc. So let's go back to this sketch menu. Choose an arc defined by start, end, then middle, pass-through point. So start and middle, I snap at the top of my vertical wall, both, and put an approximative arc here. Then in the center, I snap to the center of my bottom, and again, I placed another arc. Now I can define the subspace. So press the icon at the left tab, at the top left, and here the same. I put a point inside the subspace. Be careful that there is no line that will cut in two different regions. Otherwise, you put control into them and it tags element. And now we can see this subspace, which are number 1, 2, 3, and the same. We can define the material. So we will put the same material in this case, silt. And this is defining our subspace. Then we can define different reinforcement for this cross section. So I call the reinforcement, and here we have different ways. So shotcrete, grouting, 4 poles, filter glass, or rock bolts. We will put the first and the second. So let's define a shotcrete. We define a shotcrete. Here we have the cross section. The shotcrete can be of two different parts. It can be a permanent wall or permanent on a line or on a surface. Let's say that here it's a surface, so I draw the limit crossing my excavation, okay, with a line and just assigning it. So I put a tag and it will tag a region. So the same, I point inside, it finds the region and accept it. And it has put the tag, which is here I have only one part, so I can save. Doing the same here, and same, I can assign the material. So here it will be shotcrete that I will put, and which is attached to this cross section. For this cross section, I can define also rock bolts. So rock bolts are placed in different places. Here I will put only in the top, for instance. So the same, when I define them, create a 2D temporary space where it will plot the cross section, change the background color to 0. And now I will draw the bolt. So the bolts are represented by a line. So this line will be, I will put a bolt at the center part of the top of my excavation. So let's place a line of 5 meters, which is vertical. So here, okay, at the top here, and I accept it. And I will extend this of 1 meter, okay, inside the excavation, because I need to put an anchor. And this element, I will make some copies to have several bolts. So for that, I will place a rotate copy. So let's say with an active angle of 15 degrees, and I will make several copies. So I will create 4 copies on the left first, so like that, and I find the center of the arc. So in that way, I have radial rock bolts on the circle, and I will select these elements and make a symmetrical copy, so a mirror copy on the other side. So I have a nice rock bolts all around my circular part at the ceiling of my excavation. And then now I can tag these elements. So let's go back to my 2D sketch menu bar and say rock bolt. So I can define some parameters. I will accept my standard parameters, which is the diameter of the rock bolt. So here it's 5 centimeters. I accept the group name in the top, okay, and number, and I will select each element. Be careful if you left some elements which were already highlighted, and you see, so the same because I assign a template, so these elements are changing of color, and when I save it, I go back to the definition of here. So I can put material. My material is rock bolt. And in that way, now I have defined my cross section with all reinforcements.